So picking up where we left off, let's take a look at those examples. So if I take a look at 3 and 13, asking yourself, what's the toothpick? What's holding it all together? It's not line A, because that's not, touching 13. It can't be line B, because then 3's off. C, same problem. So if I start looking at it, there's actually no transversal. There's not a line that only touches angle 3. There's not a transversal. There's something that actually connects those two sets together. So if there's not a transversal, that's NA, there's automatically no angle relationship. There's automatically no type that is there. So that one was a little bit tricky. Now if we take a look at 10 and 13, that transversal would be line D. And so if I look at it that way, I notice that 10 and 13 are both on the inside on the same side. So D is that transversal, and those are going to be same side interior, and I'm going to write SSI for short. So then let's take a look at 12 and 11. Well, 12 and 11 don't really have a transversal because they're not separate sets. Like, they're both in the same set. So there's not really a transversal. Like, you could say D and A if you wanted to, but that's an old term. What is it called when two angles are adjacent? They're sitting on the same line. That's a linear pair. I'm going to write LP for short. When we're listing these out, so if the problem just says determine if they're this, it's okay for you to use these abbreviations and some of those identifying type problems, which is what this was. We were just identifying the angle pairs. Now, if I look at these two pictures right here, I still have 8 angles. I still see a transversal here. I still have my transversal there. But you should notice something about the other lines. From here to here, they straighten out. And the correct geometry term for that is that in this picture right here, your lines are parallel. Over here, these lines are not parallel, but right here, these lines are parallel. And if the lines are parallel, then we could start solving and we could start making statements about how those angles are related. So yes, they're corresponding, but there's a little bit more that we can do with it. The catch is that the lines have to be parallel, and typically for parallel, you'll see these little markings or some triangles like that. Sometimes they'll be at the front, sometimes they'll be filled in, but you'll typically see that if the lines are parallel. Okay, so that if the lines are parallel, hopefully you're thinking conditional statements. So right now, if I take a look, these lines are not parallel. If I look at angle 1 and I look at angle 5, angle 1 kind of looks like it's an obtuse angle, but angle 5 looks acute. I could see it more clearly with like angle 3 is acute, but angle 7 looks more obtuse. So while 1 and 5 are corresponding and 3 and 7 are corresponding, if I told you that angle 1 is 50 degrees, all that you would know is angle 4 is 50, and the other ones would be 130. That goes back to unit 1 with vertical angles and linear pairs. But over here, if my lines are parallel, notice that's obtuse and that's also obtuse, and that's because now they're connected. That's because if I told you now that angle 1 is 50, well then angle 5 would also be 50 because corresponding angles are congruent if your lines are parallel. And if I take a look at 2 and 6, so linear pair, angle 2 would be 130, angle 6 would be 130, subtract from 180. And then you can kind of use vertical angles and linear pairs to figure them all out. Essentially, what you can do is you can copy and paste those numbers down below as long as your lines are parallel. And that's your condition. That's the catch. If the lines are parallel. If the lines are parallel, then you can solve. Then you can start copying and pasting those angles from above down below. But if your lines aren't parallel, all that you know is that those are corresponding angles, but you don't know if they're congruent or not. So notice that if the lines are parallel, then we already said it, our corresponding angles will be congruent. Okay, let's look at our alternate interiors. That was 3 and 6, or 4 and 5. So 50-50, 130, 130. That's also congruent. And if you look on that poster up at the front wall, you can also start moving those angles around and seeing that they fit in other spots. So like alternate exterior would be 1 and 8. So 50-50, or 130, 130. Those are also congruent. Okay, same side interior. So there's my interior. Same side would be 3 and 5. That's not congruent, but 50 and 130 does add up to one number. Think, what's the vocabulary word if they add up to 180? And that's supplementary. And then same side exterior. So like 2 and 8, or 1 and 7. Those are also supplementary. So I like to remember it as the same side ones are supplementaries like SSS, and everything else is congruent. Now think back. If it's congruent and you're going to solve for x, remember that part equals part. That's what congruent means. Part equals part. But if it's supplementary, we're going to do part plus part equals 180. Now, you should be getting faster at the solving part, which means that for today, we're not really going to focus on the solving part. I want to focus more on the vocabulary and setting it up. You should be able to go from there to get x on your own. So let's take a look at what type of angles they are, and then how would we set it up to solve. So if I'm solving for my unknown variable and I look at this picture, I have an angle here and I have an angle here. They're on the interior, they're same side interior, so this is going to be SSI for same side interior. And if we remember, same side interior is supplementary, so it's going to be part plus part equals 180. So that SSI automatically means supplementary, P plus P equals 180. Now, I didn't give you a calculator for the notes, and you're welcome to go grab one or use one, but we can do a lot of this without a calculator. If I do part plus part and combine like terms, 20x and 24x would make that 44x. 5 minus 1 would be plus 4 equals 180. And then from there, you would just solve for x. And you could solve for x on your own if you want, but like I said, we didn't do calculators today, so let's go ahead and move on to setting up the next one. So if I take a look at these angles, okay, hopefully you're catching that they're on the exterior, so they're on the outside, and they're on alternate sides, so this would be alternate exterior. And if the lines are parallel, which they are, I mean, look at all of these little triangles, they're on all of our lines for today. Alternate exterior angles are congruent, which means part equals part. So you could say -1 plus 14x equals 12x plus 17. Or you could say 12x plus 17 equals -1 plus 14x. Remember symmetric property? And then you would solve for x from there. So let's go ahead and solve this one for practice. If I put the letter on the left and I subtract 12x, I'm going to have -1 plus 2x would equal 17. Add the 1, so 2x would equal 18. Divide by 2, x would equal 9. Now, if the problem just said solve for x, we're done. X is 9. But if it said to plug it back in and find the other angles, well, now I need to go back up here and now I need to plug it in. So I'm going to give you a minute to see if you can do that. Mental math or calculator. If you need to use a calculator, that's fine for these. But can you find these two missing angles? And if you do it correctly, you should get that they're both 125, which remember they were supposed to be congruent. So I could ask you that, but I could also ask you what's this angle? And remember that those would also be 125 there and there. And then 180 minus 125 would make those other angles 55. So once you solve for x and you plug it back in, you kind of know all the angles. So So taking a look at our next one, one's on the interior, but one's on the exterior. If that's the case, all these interior, exterior ones are automatically eliminated, and you really only have one option left, and that's corresponding, which they are, if you caught it, bottom right, bottom right. And remember that corresponding angles are congruent, so that's going to be part equals part. So that would be 23x minus 5 equals 21x plus 5. And then we're going to skip the solving, but you should be able to solve that for x. Now, sometimes you'll have multiple lines, or sometimes you'll have multiple variables. So this one has an x and a y. That's okay, because we're going to use what we know, and that's that 100. Keeping in mind that if you have two variables, we're probably going to have to set up two equations. So let's take a look first at x. If you have x minus 10 and 100, ask yourself, what type of angles are those? Top right, that's corresponding. And corresponding angles are congruent, so part equals part. So x minus 10 would equal 100. That doesn't take long to solve. X would equal 110. That's it. Now, if I want to find y, I want to use the 100 again. I want to use what I know. So if I have 2y plus 24 down here and 100 up here, asking myself, are those corresponding? Go through process of elimination. They're not corresponding, they're not interior, they're not alternate, so they have to be same side exterior, which is part plus part equals 180. So if I do part plus part and I go ahead and combine like terms, I'm going to get 2y plus 124 equals 180, and then solve from there for y. So even if you're seeing multiple variables, it's okay. Remember that you have options to solve. You can also remember that if that's 100, that's 100, that's 100, that's 100, that's 80, 80, 80, 80, because 180 minus 100 is 80. So you have options. And even if you have three lines that are parallel, just think that that 120 is going to copy all the way down. So right here, if I'm going to solve for x, notice that they're both in the top left. Those are corresponding angles. So 3x would equal 120. That would make x equal 40. Remember to solve for one part at a time. So 3x I knew went with 120 corresponding, part equals part. And now ask yourself, how are the 120 and the 6y minus 12 related? Well, we said corresponding, we can essentially copy down, right? Which would make this 120. And then ask yourself, what's that? Well, that's a line, that's a linear pair. That goes back to supplementary. So part plus part, so that would be 6y plus 108, because 120 minus 12 is 108 equals 180. Then you would solve from there. So anytime you get stuck on these problems, just ask yourself, are your lines parallel? And then are they going to be part equals part or part plus part equals 180? And remember that you could do process of elimination if you get stuck, or rewatch this video if you need more help. Good luck on your practice 3-2. You have the rest of the time to work.